everyone. We're about to dive into a topic that sounds a little, technical, object-oriented programming. But I promise, we're going to crack this code together and it's going to be super simple and clear. Let's get right into it.
Yep, we're going to learn OOPS the fun way. So if you're just starting out with programming, don't you worry, you are in the perfect spot. I guarantee by the end of this, you'll feel totally confident with these core ideas. Okay, so first things first, let's tackle that big fundamental question. What in the world is OOPS anyway?
OOPS stands for Object-Oriented Programming, and really, it's just a way of writing code that, well, makes sense. It helps us organize our code around real-world things. So instead of a messy list of instructions, we can just create a car or a student right in our code, which makes everything way more organized and so much easier to understand. Now, to really get OOPs, we need to understand one central idea. And this is a big one: the difference between a class and an object. Seriously, this is the foundation for everything else, so let's break it down. Think of a class like the blueprint for a car. It's the design, the plan, it has all the details. But you can't actually drive a blueprint, right? An object, on the other hand, is the actual car you build using that blueprint. It's the real thing sitting in your driveway. The class is the idea. The object is the real deal. And in code, it's just as simple. Let's look. First, we define our blueprint using the keyword class. See it there? Class car. That's our plan. Then that second line, car, my car equals new car, that's us on the assembly line actually building the car. We're creating a new object, and we've named it my car. See? That's easy. So if a class is our blueprint, what kinds of details go inside it? What actually makes up the design? Let's pop the hood and take a look. A class usually has two main parts. First, we have properties. These are just variables that describe the object, like its color. It's the what it is. Then we have methods. These are the actions the object can perform, like a start function to get the engine running. It's the what it does. So properties describe it, and methods give it actions. Now, whenever we create a new object, we need a way to set it up properly from the get-go. And for that, we use a very special method called a constructor. This little piece of code is so important because it's the very first thing that runs the moment our new object is born. You'll notice the constructor always has the exact same name as the class. See? Public car equals question mark. This code runs automatically whenever we type new car. Think of it like the ignition switch. It's where you can set up all the initial details, like setting a default color as soon as the car is created. Okay, let's talk about privacy settings for our code. These are called access modifiers. If you make something public, anyone and any part of the code can see and use it. But if you make it private, it's locked down. Only code inside that same class can touch it. This is so important for keeping our data safe and preventing accidental mistakes. All right, you've got the basics down. So now let's get to the really exciting part. The four main pillars of OOPS. I like to think of these as the superpowers that make this style of programming so awesome. Here they are: encapsulation, inheritance, polymorphism, and abstraction. I know, those are some pretty big, fancy words. But don't worry, this is simple. We're going to use some easy analogies to make them crystal clear. Let's understand step by step. Our first superpower is encapsulation. The main idea here is to bundle an object's data and the methods that work on that data all together into one neat package. It's like a protective capsule. The important stuff is kept safe inside, protected from the outside world. This is how we protect our data from being changed by accident. Next up, we have inheritance. This one is all about code reuse, which saves us a ton of work. Imagine you have a general animal class that knows how to eat. Well, you can then create a dog class and a cat class that both inherit from animal. That means they automatically get that eat method for free without you having to write it again. It's so efficient. Pillar number 3 is polymorphism, which is a fancy word that literally means many forms. And it lets one single thing, like a method, act in different ways depending on the situation. Think about the word open. You can open a door, open a book, or open a file on your computer. Same word, different actions. That's polymorphism. It makes your code super flexible. And our final pillar is abstraction. This one is all about hiding the messy, complex details and only showing the simple, necessary stuff. When you drive a car, you just use the steering wheel and pedals, right? You don't need to know how the engine, the transmission, and all the electronics are working together. All that complexity is hidden from you. Abstraction does the exact same thing for our code.
Phew, we covered a lot of ground, but you did great. Let's do a super fast recap to make sure all these new ideas stick.
Okay, let's run through it. A class is our blueprint. An object is the real thing we build. Properties are the data, and methods are the actions. A constructor is that special method that gets everything started, and access modifiers are our little privacy settings.
And don't forget our 4 superpowers. Encapsulation protects our data. Inheritance lets us reuse code. Polymorphism gives us flexibility. And abstraction keeps things simple. These 4 pillars work together to help us write code that's clean, powerful, and easy to manage.
And just like that, you've got it. You now understand the core ideas behind object-oriented programming. You've learned the language, the concepts, and the big picture. And now you are ready to think like a